right. But with that, I guess I'll turn it over to Eric. And I think I gave him 25, 30 minutes and kind of think we'll have some discussion to his presentation after he's done. And then actually Ehsan Ghane there at Michigan State University, who most of us are familiar with, had to record a presentation and send it in to me. Unfortunately, he got called up to an admin meeting today, so he had to back out at the last minute, but he was gracious enough to give us a 15-minute presentation about some of the practices we talked about. And I think we have enough content experts on the call here today that we can probably discuss some of the topics that maybe he didn't get to in his discussion. But with that, Eric, if you want to go ahead and share your screen and jump on in here.
Yeah, can you hear me okay?
Perfect.
All right. Well, I really appreciate the opportunity to come and speak to everybody today. And again, I think where my expertise leaves off, I hope a lot of you on the call is where it picks up. And so what I can tell you is what we've been studying about atmospheric delivery of rainfall. That's really what I want to talk about, and some of the changes we've observed. And then also just anecdotally, some of the things I hear as I'm out kind of traveling the country, speaking with a lot of growers. And you're right, this has been one of those years where you kind of feel as though it's a lot of haves and have-nots. Some folks have had just a tremendous amount of rain, and the crop looks amazing in certain places. In other places, we've got flash drought scenario going on. And it's funny because the number one question I always get asked is, well, how do I do a better job of handling the variability in rain? And I say the only thing you can do is to maintain your soil health. Like, there's nothing, if you do that, plus these techniques that are going to be talked about today, you're basically removing the influence that the atmosphere has in its highly variable nature on what we do. So let's just talk about that for about 25, 30 minutes and show you what I know, give you some stats, maybe point our finger across the country and world at some things going on. And then hopefully that sparks a good discussion for everyone else today. All right. By the way, at any point, if anybody wants to just interrupt me, just go right ahead. That's okay. I don't mind that at all. But I will share my screen here, and hopefully you can see my first slide. Is that all showing up for everybody okay? Got my title there?
Yep, looks good.
Good. So yeah, in the background, we've got the earth spinning around there. And it's funny because what really sparks every bit of discussion we have right now is that Earth has got this incredible mixture of gases in the atmosphere, such that it has this temperature range that supports water in its liquid phase, its gas phase, and its solid phase, of course, which is ice. And that is ultimately the exchange of energy between those three phases drives a lot of the weather systems we're going to talk about. It's a truly unique planet. But I've titled this one "Understanding Rainfall Variability," and I'll just tell you something. For everyone that's going to take the information that we study and present, it is always going to be a hyper-local application of it. Would you agree? In other words, if we're talking with growers, if we're talking with land managers, they're all going to be experiencing this. I love this video here. You're just watching the rain like come across the lake, right? I mean, this is what we're ultimately dealing with. It's how is the moisture locally being delivered and handled and managed, and this is just the world in which we live. So let's get in and talk about that, because we of course see incredible pictures like this one. This is of a massive downburst in Arizona a few years ago. This picture went viral after it was taken. In fact, you can also see how the bottom of this kind of spreads out horizontally. That just tells you that the downdrafts inside the storm are probably maybe approaching 100 miles an hour. That's when you get this almost foot-like feature as it hits the ground. And then at the same time, let's mute that. You can also get these incredible events like this one, just hyper local, extremely heavy rainfall. And we have to understand what to do with all of that water. How can we manage it? How can we prepare ourselves such that events like this are not kind of disastrous for operations and things like that? And then I had to toss in one last picture here. This is Virga that's lit up by a sunset. So what you've got here is rain that's falling. In fact, some of this might even be some snow that's falling from this cloud, but evaporating in the very dry air near the surface. And as it does so, none of that hits the ground. We saw a lot of that right here in Champaign, Illinois in the last 24 hours. The radar detected precipitation, but none of it got to the ground because it's been so very dry. So when we think about all of this, I'm going to divide the country real quickly here. We're going to divide it right here on the Rocky Mountains, the peak of the Rocky Mountains. Because if you are to the east of the peak of the Rockies, let's just roughly draw a line like that. the primary source of all of the moisture is going to come from the Gulf of Mexico or the Atlantic. And that's why the precipitation pattern increases as you get closer to the Gulf. When you're on the other side of the mountains, we are primarily talking about Pacific moisture. And as a result of this, it's really splitting the country in two on trying to understand how precipitation should be discussed and ultimately how the management techniques should be shaped. It's basically in the mountains and then throughout the plains and prairie, and then the small mountain chain over here called the Appalachian Mountains. So this beautiful figure that was produced using data from PRISM, that comes from Oregon State, went through and made almost like a relief map of precipitation totals.
Wow.
And isn't that just it's kind of a breathtaking view here to see where the heaviest rainfall is across the country. We can also look at this in terms of where we should expect to see the greatest variability. And a lot of that discussion is going to come down to things that are changing across the Western United States. Now, just to show you how hyper-local these events can be, can I just take you to last night? Last night, the winds and the low level of the apps were pulling in a lot of moisture out of the Gulf of Mexico right here. And near the surface, there was a cold front, a weak one that stretched right from parts of Missouri over into Illinois and eventually toward the Ohio River Valley. And as that warm, moist air overran that front on its leading edge, it just started to rain. But the upper level winds were coming out of this direction, almost right over the top of the front. And as a result, when the rain began to form right in through here, it just kept going over the same location. And as a result, we saw this last night. So if you want to talk about some real motivation behind what we have to talk about today, it's seen right here in this animation. Coming out of Missouri through southern Illinois, and then today into parts of Kentucky and West Virginia and Tennessee and southern Indiana and Ohio, we have seen just a tremendous amount of rain that has fallen. And this morning in St. Louis, they woke up to one place just outside of St. Louis, right over here, where over 14 inches of rain fell. This very narrow band of extremely heavy rainfall, just hyper-focused in this particular region. So if you need an example from today on why the discussion we're about to have is so critical, it happened last night and this morning right in and around St. Louis. By the way, some of the data we've been collecting and keeping from St. Louis for so many years helps us to put kind of some statistical bounds on what just happened. And I'd like to show you what some of that looked like here. So this table's kind of ugly. And when I give you my presentation, you can go look this up on your own, but it's going to be right over here, hyperlinked on the right. Now, we saw that the heaviest rainfall just outside of St. Louis in the 24-hour time period was greater than 11 inches. And what we find is that the probability of an event like this occurring on any given day is somewhere between 1 in 1,000 and 1 in 10,000. So if you start hearing people today talk about this being a 1,000-year flood event, there's often a lot of confusion about that. Folks think that that means that a flood like this won't happen again for another 1,000 years. That's not how that works. Of course, it means that the probability of a flood of this magnitude over the time period in question, like a 24-hour time period, is 1 in 1,000. And it's possibly even higher than that, because when you look at the actual precipitation frequency diagram, 14 inches was had. If you could extend this all the way over to where this line would cross, I think we're approaching something more like a 1 in 10,000 year event that happened for St. Louis just last night. When all that water comes through, just remember, some people are not getting it. One of my jobs here at Nutrien Ag Solutions is I keep track of this all over the country. And I live in Champaign, Illinois. And while all of that heavy rain just fell to our south, we are actually in the middle here of a drought that's unfolding. Go back to late May through June. We had one decent event just after the 4th of July, but it's been extremely dry in this area. We're now at about 82% of normal precipitation. You talk to growers in this area, those folks that have the healthiest soils, the best drainage practices in place, they're the ones that have the best looking crops around here. It's the areas that have a lot of compaction. It's the areas that have not been tended to as well that the crops are not looking as good. So just something to think about. You go from one side of Illinois to the other, and you have a huge disparity in total rainfall. By the way, if you're interested in where to find all of these statistics, I can actually point you to where I put them every single day. So you can get updated graphics if you want and keep close tabs on how all of this works. By the way, I do apologize for some of the noise in the background. I have a contractor here working today on the back of my house. So you might hear a couple of hammers going or the compressor going. I apologize for that. But this is where we dig into kind of the nitty gritty of what I want to discuss with you today. Because back at the beginning of 2021, we had what we call the new climate normals released. So once a decade, we update the averages. And the way we get the averages is we look at a 30-year history for a particular day and start to calculate what those numbers might be. So when you look at this particular map, what it's showing you is what happened when we added the new data to and took off the old data. So we got rid of the 80s and put in the 20 teens. And the big thing we want to look at is over here on the right, the precipitation change. And again, do you notice the different split on the Rocky Mountains? There's been a decrease in precipitation west, while much of the eastern side of the United States has seen an increase. And I want to talk with you about what we've learned as to why that's the case. It boils down to understanding some of the work by this guy. His name is Carl Gustav Rossby. And I hope you can hear me without too much of that saw going in the background. I apologize for that. But Carl Gustav Rossby was a critical part of atmospheric science history because of the work that he did post-World War II. One of his jobs was to study and understand how the behavior of the jet stream, which often goes into troughs and big ridges and troughs like this, how it maneuvers and manipulates itself across, well, the northern hemisphere. Whenever it jumps up into a big bulge like that, we call it a ridge. It tends to get hot and dry. Whenever it dips down into a trough, it tends to go over wet. Now, what he studied, and this is what's so important, is that the typical wavelength from a trough like this one to the next ridge is about 2/3 of the width of the United States. Now, why am I telling you all of this? I'm telling you that because of this research, which was published just a few years ago. Now, this part of my talk, I think, is most critical to you understanding why we've observed the changes we've seen across the United States. Ready? If you look at this top figure, which I pulled from that journal article, okay, what you find is that here across the western side of the United States, the red color means that we have seen an increase in the ridging events across the west, meaning the jet stream, more often than not, over the last 70 years, has preferred to do this. Now, what does that mean? If we have more ridging, especially during the summer months in the west, it gets hotter. Since 1948, we've observed an increase in temperatures from June through August for the Western United States region from an average of about 66.5, now up to 69.5. That's 0.4 degrees Fahrenheit per decade, or about 3.5 degrees in total. While that's all occurring, we've had more troughs of low pressure around the Great Lakes. The net effect is increasing evaporation rates in the west, decreasing them in the east, while increasing the rainfall rates in the east. This is the most important bit about climate change research that's happening across the United States, the changes, the systematic changes in the jet stream. Now, in the west, it's causing major problems. You go back to 1895 and look toward present, we have seen that when looking at something called the Palmer Drought Severity Index, that the values of that index are getting lower and lower with time. And the lower they get, the greater the risk of drought development. You increase the temperatures, you also increase the vapor pressure deficit. That's what the D is. It's the lack of moisture in the system, in the atmosphere. Now, this was a major problem this year for our Western friends here. And some of you might be out west. I'll show you something that you probably are quite familiar with. You go back and look over the last year. Normally, do you see this kind of faint blue shaded area? That's the normal rate at which we accumulate snow water in the mountains. We were on pace for a great start to the year in December, and then it flatlined all the way through the remainder of the year. Even the stuff that came in April was still pretty low compared to normal. What happened was the jet stream just avoided California. It went into the Pacific Northwest. So the big concerns right now, in other words, what are they dealing with in California in terms of managing water? It's the reservoirs. And they're big ones like Lake Oroville and Lake Shasta. Well, Oroville's currently at 42% full pool and Shasta's at 37%. And the water that's in these reservoirs has to last them all the way through October, because it's not until we get into October that we start to see precipitation returning to the Mediterranean style climate that California has. So the West right now, with the heat it's just seen in the last week and the heat it's experiencing, has very high evaporation rates. We've had wildfires break out as of late. The reservoirs are low, and the issue of drought expansion across the West has been quite bad. You've heard a lot of stories as of late around Lake Mead, and Lake Mead, which is right in through here, of course, is at historically low levels. There's been lately some better moisture coming up from the monsoon in this area, but it's not enough to outdo the deficits in the Colorado River. So the drought that's anchored from the Western United States to the southern part of the United States is a multi-year drought that we're dealing with here, and it's going to continue to be a problem as we go forward. But look around the rest of the country. Droughts developed in the Western Corn Belt. It's developed in a big way in the Mid-South. It's here in pockets in the Midwest. It's been in the Southeast, and it's also been very dry in the interior parts of New England. You see, when you think about what's got us set up for this, though, and why there's been more drought risk west than there has been east, okay? Because the drought we're experiencing right now in the central and eastern part of the United States is more rare than it is in the West. It boils down to the oceans. The oceans are our great climate regulators, and this is what I want you to see. You see that pocket there right now? That map is made on July 25th of this year. That warm water in the North Central Pacific is a part of a longer-term trend toward a much higher heat content in the North Pacific Ocean. And this is why this is so important. The more heat we put into this part of the North Pacific over time, the more the jet stream wants to go around it. And if it goes around it, it tends to ridge right in through here, while there are troughs there. So do you see how we're building this story of the West being too close to the heat and dry conditions, whereas the Central and East more often than not sees the wetter conditions? And that's the main thing I want to tell you here at the beginning of this. It's all about that pattern. We're seeing it in summer. We're also seeing it in winter. What you're getting over here now, look at the map that's on the left. This is the typical January through March climate pattern. We've seen lately that there are more ridges of high pressure forming here. In other words, the jet stream doing this. And then what happens is it dives into the east. And as a result, there's better snows in the Cascades getting up into the Northern Rockies, while the Central Rockies and the Sierra Nevadas are seeing less snow. You see, the story here is about Western snowpack delivering the moisture that's needed. So when they talk about water management, it's all about snowpack, river movement, and reservoir storage. That's the change in snowfall. It's decreasing here, increasing there because of these long-term systematic changes in the flow of the atmosphere. Now this year, take a look. The jet stream came screaming out of the Pacific, and where did it target? The Northwest, not California. So across the Northwest, it was very cold spring and early summer. Some places set record cold temperatures. We had snow in the mountains in Boise, Idaho through mid-May. I don't know how many of you are Stephen King fans, but there's a real Timberline Lodge that's in Oregon. This is what it looked like on May the 12th. Normally they're having really warm spring weather. It looked more like what we see in the movie, The Shining. And this is what the Cascades look like on May 20th. Over 500% of normal snowfall, while to the south in California, they were in major deficit. So you can see the disparity occurring across the western part of the United States. And all of it had to do with these strong winds coming in here. By the way, this year, those strong winds also gave us the flooding rains we saw in Yellowstone, which is right in through here. Do you remember seeing this? In Yellowstone, we had the bridges collapsing due to the floodwaters there. You probably saw this video on the national news. It was the house that was floating down. This was on the Montana side of things, just floating down the river here. And they shut it all down. I mean, we had rock slides that were happening in there, just a terrible, terrible setup. But you go south of there, down into parts of Colorado, you get down into Nevada, you get down, down into Arizona and California. It was extremely, extremely dry. By the way, I did want to show you one crazy video. If you think that's a bad rock slide, watch this one. Do you see right up here at the top? Now, this, of course, was not from this year. This was back in 2013. But this particular video, watch the top of this mountain collapse here. So you talk about water management. Places that have a lot of terrain have entirely different issues to deal with than places that are flat. And what's going on right now is the top of that mountain is rolling down the hill and nobody knows it until about right here. And there comes all the mud. And watch this, ready? There's the top of the mountain rolling over. So we have much different problems depending on where you are in the world with respect to water management. Now this year, because the jet stream came screaming in like this, the northern plains of the United States, specifically the Red River Valley of the North, saw one of its wettest springs on record. And as a consequence of that, near the Red River of the North, we saw massive flooding. You know, a year ago, this same place was in deficit in up to 40 inches in terms of snowfall, which meant they went into the 2021 season with drought problems. Now in 2022, it was massive flooding. And this extended into southern Canada. This is in Manitoba back in mid-May. You can see that this particular guy's name's Harley. He couldn't get to his home for almost a month because of the floodwaters here, could not get across them. You see, this is about precipitation variability. And that's what I want to talk with you about as I kind of push toward the end of what I'm going to share with you today. Because while the North was so wet, parts of Texas this year are exceptionally dry. If I've been telling folks this all spring and summer, if you would have taken this picture sent to me by Joni Blount and you were to make it black and white, put it in a book about the Dust Bowl, nobody would have been any of the wiser, right? Because it looks exactly like what we've seen down there. Andy Carthel sent this video out last week showing us just how dry things were on his cotton fields in Texas. Water management in the rain shadow of the Rocky Mountains is exceptionally challenging and boils down to also a management of the groundwater. But you ask, what are the changes like? Well, since we're talking about Texas, I'll just tell you, going back to 1895, the last 40 years, 50 years, in fact, going back to 1970, we've actually seen a nearly flat trend in total precipitation. But that's not what I'm concerned about for Texas. It's the annual variability in rainfall, which has been enormous. Because this year, from the Mid-South into Texas, many locations are currently sitting between 10 and 40% of the normal precipitation. A year ago, plenty of rain, cool weather, and it was one of the best growing seasons on record for the Southern Plains. That's the difference I'm talking about here. I study this for one big reason. And as I kind of pull into my last 5 to 8 minutes here, the one thing that I study most often is the Midwestern part of the United States. You see, when you look at yield variability county to county, what often causes your high variability, which is seen here in these darker shades, is moisture variability. Whenever you see the whites going over into the blues, that's either where we have the capability to irrigate or there's such good soil that to really develop drought that destroys yields is quite challenging. So I'm going to ask some questions now about the Midwest, because I know a lot of you are from the Midwest. And these are some very important statistics I'm going to give here at the very end. I've been preaching on these statistics now for several years. Just take a look at what I've got. When you look at the April to October timeframe, that would be our growing season, for the primary corn and soybean belt, looking at data from NOAA going back to 1948, the beginning of the reanalysis time period, we have increased total precipitation through that area by about 5.5 inches. So we're wetter. Why are we wetter? More often than not, there are troughs of low pressure delivering the rainfall in the Midwest, because more often than not, there's big ridges over the West. That's Carl Gustav Rossby's research. But as we've gotten wetter, what's important to note here is that it's the precipitation delivery mechanism that's really changed. Early in 2020, I finished some research where I used the radar data era combined with rain gauge information to look at the frequency of heavy rainfall events. I had read from the IPCC, I had read from the National Climate Assessment that we're starting to see bigger rainfall events happening in the Midwest. I'd heard that from even farmers that have anecdotally shared that, and I just wanted to prove it to myself. That's good science, by the way, to repeat others' work to see if you find the same conclusion. And that's what you've got over here on the right. It's frequency on the y-axis versus year on the x-axis. And we're looking at the number of times across Iowa, across Illinois, where we've had rainfall events bigger than 2 inches at every grid cell. And in Iowa, that frequency has tripled since 1980. In Illinois, it has more than doubled. And it doesn't stop there. It goes into other states. We've noticed this increase in rainfall frequency and rainfall amount affecting our workable field days in spring. So for example, in Iowa, the upward trend in total spring precipitation, plus the doubling of days of more than an inch of rain in April and May, has reduced workable field days by 4. That's using the USDA's formula for calculating a workable field day. Now, this hasn't really impacted planting because we have bigger, badder, faster planters. But had we not made those technological advances, this would have really slowed us down for planting. In the state of Illinois, my home state, take a look at the statistics I wrote inside the state over there on the left. It's interpreting the graphical data on the right. During our growing season, we've seen an increase in the minimum temperatures of 3 degrees. Now, what does that mean? Well, the minimum temperature is often set by the humidity levels in the atmosphere. You know this. When the temperature drops off at night, it gets down to the dew point. Well, if you've increased the dew point, you've increased the humidity levels, you've increased those minimum temperatures, and that has corresponded to a net increase of total available water for precipitation. That's what PWatt is, precipitable water, by 15%. Net effect is in Illinois and surrounding states, the atmosphere is more juicy to deliver more precipitation. That translates into a relative humidity increase of 6%. Now, relative humidity, in my opinion, is a useless term for the most part because it's always relative to temperature. So we have to make sure we know the temperature in order to understand that. But what we're seeing here is an increase in moisture. It's the same thing for our neighboring state of Indiana. It actually gets more in terms of total precipitation as you go toward the Ohio River Valley. Indiana, since 1948, has seen an increase of 6 inches in total precipitation. But just like the other I states, look at the variability here in total precipitation. Indiana has also seen a tripling in the frequency of their heavy rainfall events. The big ones are Kentucky and Tennessee, where they have seen more than a tripling of their heavy rainfall events, and parts of Kentucky and Tennessee are now 7 inches wetter than they were in the 1950s and 60s. So just something to keep an eye on here. Just like I talked about with Illinois and Iowa, there's also been an increase in dew point temperature and precipitable water. So we come back to this map. Now you see the context behind that map that I showed you earlier, looking at the systematic changes when we calculate our climate normals. And what you've got in this particular case is major increases east with decreases to the west, primarily blamed on the changes in the position of the jet stream systematically over time. I found it quite interesting that back in, I think it was 2020 when I saw this, there was a farmer who asked, what is the best on-farm investment that has the highest return on investment? And as you can see here, he had 188 replies. Now, I've been joking about this since Andy put this out there, but when he put it out there, of course, the most common reply was your best on-farm investment is to marry rich. But as you get beyond that, you'll probably know, and this won't surprise anybody, the biggest ROI for one of these farmers in the Midwest is to put in pattern tile. That's what they all told him. And that pattern tile, you know what that does to increase your resilience against heavy precipitation events. I just want to make a point here. I've been talking a lot more about heavy precipitation events, but I want to make a point to tell you that we see high precipitation variability. So, for example, fall of 2020, we saw drought expanding from the Southwest into the plains all the way across the Corn Belt, extremely dry soil. And I noticed that someone earlier said they were from Minnesota. I pulled a picture from Minnesota and one from Illinois. This picture's from Illinois showing one of the field scars from a fire that we had during our flash drought event in 2020. But this one's from Minnesota. I know it says Southeast South Dakota, but that's where Andrew's from. He was in a Minnesota field when he took this. The fire went ripping through under those dry conditions, just leaving some of the ears of corn hanging. By the way, he did harvest that. And reported that that was some of the lowest moisture corn he's ever harvested. So I don't think any of us would be surprised to hear that. But on the flip side, do you remember last harvest? These are the precipitation ranks by climate district from the month of October last year. And across Illinois, Iowa, Indiana, Michigan, getting back up to the Red River Valley, even here in the West, one of the wettest falls on record. And we had a lot of flooding. I've been showing this picture for 5 years now. It's just a reminder I put out there that when you think about where the resiliency comes from when dealing with excess precipitation or major deficits, it's all about how to effectively manage water. And this is not how we do it. It's about talking to research institutions. It's about looking at the local extension offices and what they're doing. It's about talking to industry professionals like myself, figuring out what we're hearing and seeing that's working very effectively. We want to make sure that those practices go into place because the world is dependent on our ability to manage that water to grow the food, fiber, and fuel that we have. And so we get to this point, and this was brought up at the beginning. A couple of years ago, I got to witness them putting in a saturated buffer. I'd never seen something like this before in my life. Now, this was 2019, where we were extremely late in planting. But even in some of the best dirt on the face of the earth, which you see here, still need to have the ability to manage that water, keep it when you don't, when you need it, and get rid of it when you don't, but do it in an environmentally responsible way, like putting in one of these buffers. It was an absolutely incredible thing to see. To be honest with you, what I was most amazed with was that they dug down 9 feet and it was all topsoil down there. So this guy's got a really, really good farm over here near the Embera River. Now, just looking at my time, I have gone exactly 30 minutes. I didn't talk much about the East Coast. I didn't talk much about hurricanes in this particular 30-minute dialogue, but I wanted to stop here and pass it back off and see where we can go with some questions and stuff here.
Actually, Eric, one of the first questions that we had there was how far east does this trend go? So,
yeah, well, the problem with it going east is primarily because, well, I had that next. Hurricanes are very disruptive to the precipitation statistics. So you're like, well, what about North and South Carolina? Or what about coastal parts of Louisiana or even up the East Coast? When we look at the precipitation pattern during, for example, late summer and fall, what really increases the variability is whether or not you had a big tropical cyclone that hit. I just tossed in one of my favorite animations here from 2020, mid-September, when we had 5 named systems out in the open Atlantic and in the Gulf of Mexico. Last year, there were 21 named systems. In the last 2 years, Louisiana's been hit 10 times by tropical systems. This one, of course, being the worst, Hurricane Ida, coming in at Cat 4 strength. And if you see me present this year, I've shown this stuff about Hurricane Ida. What makes it so difficult to really tell you about the longer term trends with precipitation is that Ida came through, Matthew, what about Isabel, all these massive hurricanes that can produce 30, 40 inches of rain. Or how about Harvey, which hit Houston, dropping 57 inches of rain in 5 days. When they come through, they can do a tremendous amount of damage. By the way, Ida put down 10 feet of storm surge. That's not rain. That's just ocean water getting blown in. And it did this to downtown New Orleans. And I guess maybe what I can finish with here on hurricanes is that when you look specifically at Hurricane Ida, remember that it directly hit the Mississippi River, which drains over 40% of the land area in the lower 48. The Mississippi River and its tributaries make up the largest system of navigable water space on Earth. And what happened was Ida stopped the river. This USGS gauge here showed that Ida reversed the river, giving it a negative discharge rate when those winds were right over the top of it. If you are out east, can I give you a resource? Let's go to it right now. It's called Climate at a Glance, CAG. There you go. And you can come in here, and I'll make sure you all get this link, and you can look at some of the graphics I made. So let's just pick a state real quick. How about we look at precipitation? Let's do a 7-month time series from April all the way to October. And I'm going to pick North Carolina. I got to head out there soon. Let's talk about North Carolina. I want to display a trend from 1970 to present, though. And we're going to click this and see what it shows. So notice that since 1970, they've been increasing about 0.8 inches per decade. But look at the variability in all of this. That trend line, though, tells you what's going on. But you can get all the statistics and download them. And it's not just by state. You can get it by division, by county, by city. This is NOAA's data repository. I'll make sure to put this link in the chat so that anybody that wants to get access to it can have it. But this is our most trusted source on historical weather information. Were there other questions that came in there? Let's see the chat here.
Yeah, you want me to read it to you there, Eric, or do you got it in the
I've got it
chat?
pulled up here. It says, how much of the narrow bands of climate are we seeing today is the change in climate extremes, and how much is the difference in our ability to see more detailed picture with improved? Oh, great question, Mark. There's no doubt about it. Our ability now with our modern radar network of 160 radars, plus our new rain gauges, has dramatically improved our ability to remotely sense precipitation events. What we do, though, to basically get a better picture of what's going on in the past is we can statistically, I don't know if the word's manipulate, but statistically change the data in a way that helps us remove that bias so that we can understand the longer term statistics. But you're 100% right. Normally, when I'm looking at rainfall data, I don't often go back before 1980 when the modern radar network was initially established. So that kind of gives you some perspective on that. But Mark, great question here. Some other questions here. Eric, this is from Alvin. It appears that the frequencies and quantities across the growing season, which keeps crops roots alive, are more important than total annual, total rainfall annually. Alvin, you're 100% right. It's all about the frequency events, not the total. You could have a year where you've only got 70% of rainfall, but if it was perfectly timed, you'll have bin busting crops. In fact, the crop responds to drought stress and in a way that oftentimes, if the rainfall is perfectly timed, you get your best yields. But ultimately, what we want to do here when we think about water management is how do we remove the impact, the negative impact of that variability? That's something I really want to think about here. And he just has another comment there about root deaths per cubic meter based on root zone soil moisture. Great. Keegan put a question, what are the trends for dry periods during the summer months? It is the flip-flop. It's the opposite of what I just showed you, Keegan, in terms of rainfall intensity increasing, frequency increasing. So what ends up happening is we tend to have bigger events followed by longer dry stretches. Now, I don't have the exact number on what that is, but anecdotally, I can tell you that normally in summer, when we get these big rainfall events, it's not uncommon to have 12 to 15 days of nothing that follows it, which is why soil moisture management is so critical to keeping the water where you want it and where you don't want it. Guys, what we're doing here, though, is with my 35-minute talk today, we are opening up what could be an entire semester's worth of lectures on this particular topic. So I hope I just sparked some questions today that we can do a little more digging and research into. Are there other
and I think we do have a few more minutes, I think, for some more questions for Eric. If anybody, you can either unmute yourself and jump in to ask, or feel free to enter into the chat. So I was reading a Bomber Mafia there by Malcolm Gladwell, Eric, and is that how they actually discovered the jet stream was in the Pacific there, or is that kind of just fabricated a little bit to make that story better?
No, that's 100% right. I've read the same book. It's a phenomenal book. Yeah, basically, we built the B-29. We tried to use it in the, over in Japan as a bombing, of course, effective bomber. The issue is that when it got up in the jet stream level winds at 30,000 feet, it wasn't fast enough to fly against those winds. We actually didn't even fully know that the jet stream was truly there. And so if you know the whole story, now this is a summer view, so the jet stream is right up here. If you know that whole story, they brought in General Curtis LeMay, who basically went through and just cleaned house and said, why can't you hit all your targets? And they went and launched a bunch of weather balloons, figured out that the jet stream winds were too fast to fly against or fly with. And so they started to bomb at night, low to the ground, which was unheard of, but it was a pretty effective campaign. So yeah, that is basically where we discovered the jet stream. And that guy I told you about, Carl Gustav Rossby, he was kind of the predecessor to that research. This guy right here that we discovered in the 40s to figure out more about what that jet stream does. In fact, you know what we call these? These long waves in the flow of the jet stream are called Rossby waves, named after Carl Gustav Rossby because of that. So no, Bomber Mafia, phenomenal book. I recommend it to everybody listening. Excellent bit of research on World War II and the discovery of the jet stream. That's part of it. Yeah. Good question or good comment.
Yeah, great. And I might actually put Levi, if you're still out there, I might put you on the spot. You're kind of the advocate for the Red River Valley. I don't know if you wanted to provide some comments just on kind of what you guys are facing up there or not. I know you generally like to put a few comments in, so I'm not too afraid to call on you.
Yeah, it's actually an interesting topic. We in the Red River Valley are facing the more things I handle are political, just so everybody knows, is I'm not a scientist. I'm more an advocate for the ability to do drainage water management, and the key there we try to preach is water management. I'm just been writing a lot of notes and taking a lot of this down, because you do make a strong case that no year is ever the same. I don't know how many people are familiar with the Red River Valley, but we do have $1 billion or a couple $1 billion diversion going around the city of Fargo that's being constructed. And the sales pitch has always been 500-year flood. But those of us that live outside of the walls of Fargo deal with overland flooding quite a bit. And a year will go by and we'll have dust bowls, and I do have some pictures on my computer I could pull up, but we have massive drainage ditches that full in with Red River Valley topsoil that take excavators and scrapers to clean them back out in the spring and put them back in the field. And it's mind blowing to me that it's 2022 and we're dealing with what my grandparents or great grandparents dealt with. So I guess those are just some comments. I wish I would have known this gentleman's name before, because I could have probably had him talk about 47 times across North Dakota and northern Minnesota in the last 3 years. So don't worry, this won't be the last time we chat.
Is this the project you're talking about right here?
Yeah, it is. And the diversion's what it is. What it is. The citizens of Fargo, apparently, that's what they're going to do to stop their flooding issues. But we still have 9 million or 12 million more acres we have to worry about that periodically are underwater. This year it's the northern end of the valley. Next spring it could be the southern end of the valley, or it could be, the central part of the valley. No spring is ever the same up here, but the water does flow north. So I don't know. You just hit on a lot of things where I was just kind of very impressed. So they're not often am I speechless. Thanks.
Oh, there is a first.
Yeah.
And sounds like Levi's signing up for more speaking gigs there, Eric. And actually, we had a comment or question from Alec Eccles too, asking, do you ever present kind of these changing precipitation stories or presentations, I should say, to the people out in DC, so like Robert Bonney or anybody else, involved with the NRCS and people that kind of make the decisions behind, priorities for where our conservation dollars are spent?
I have requested those opportunities, but no. I mean, I speak at about 150 events a year, but a lot of times I'm more preach to the choir than preach to the congregation, if that makes any sense. When I talk to people that are dealing with these issues, they all just nod their heads like, yeah, this is it. And to be honest, the folks that talk most about this are in the northern plains. They're either in the Colorado River Basin or they're in the Western United States, somewhere. That's where the issues come up, where we're talking about water most often. So it's kind of the haves and have-nots. But it'd be something I'd like to, I wish that I could kind of bend the ear of some people that just need to get a very straightforward answer as to what's going on without any extras, if you know what I mean, and just say, hey, this is what we're dealing with. And if we're wanting to become more resilient and we're wanting to increase, truly become sustainable. And a lot of people just toss that word sustainability around like it's nothing, but in other words, to be able to continue to deliver what we deliver now in the future, we have to think about these things hard and think about what it takes to manage water resources, because there is disparity across the country that needs to be investigated and discussed.
Yeah, perfect. I think that's a kind of a great segue here to Ehsan's video recording that he sent to us. And
I'm going to be talking about how to deal with excess water in a changing climate. As we know, climate change is affecting our precipitation patterns. So let's see what we can do on the farm and also downstream of the farm. Our planet is affected by climate change. It's caused by greenhouse gas emissions. So the change in climate causes heavy rainfall and drought to occur more frequently. So you may have a really large event, rainfall, and it may come in a very short period of time, and it's going to cause problems. So let's take a look at what we can do. The first idea that comes to our mind is that maybe we could go narrower with the drain spacing to be able to remove the water more quickly, but narrower drain spacing is going to cost more money. It's expensive, and there are other ways that we could actually deal with this heavy rainfall without having to limit our options to just narrower spaces. So let's take a look at those options. So let's take a look at the methods for adapting drainage systems to those heavy, extreme rainfalls that are becoming more common in a changing climate. First, you've got to make sure the drainage system does not have an underperformance issue. For example, root clogging, sediment clogging, ionocal clogging, or undersizing of the main, and compaction of the soil that could limit water flow into the pipe. So those issues, we don't want those issues. If you want to learn more about those underperformance issues, I invite you to read this extension bulletin by Michigan State University. It's called Why Do Subsurface Drainage Systems Underperform? So let's say we don't have underperformance issues, we know that. First thing you need to look for is improving soil health. So let's take a closer look at that. Improving soil health is vital for the proper performance of the drainage system. Example practices that you can have are reduced tillage, cover crop, diverse rotations. Improving soil health leads to building soil organic matter, and that leads to building better soil structure. If you have a better soil structure, you're going to have increased infiltration and reduced surface runoff, and that's going to help water reach the drain pipe more quickly, as opposed to this scenario of having a really good soil health is a poor soil health where you got soil compaction, poor soil structure that's going to limit water movement to the pipe. So that's key. That's the first thing you need to think about as we move on to the next methods. So for the methods for adapting drainage systems, we talked about no underperformance issues and improving soil health. So let's take a look at some of those methods. Let's say you have an existing drainage system. One way is to combine more drainage with subsurface drainage. Another way is combine surface drainage with subsurface drainage. So let's take a closer look at these two. This is a mole plow. As I mentioned, for an existing drainage system, when you want to combine wall drainage with subsurface drainage, you can see the bullet expanded a shank and it's pulled by a tractor, and it creates these cracks, as you can see in the next slide, that helps water movement towards the pipe down. And this is another diagram that shows those cracks. This is very suitable in a heavy clay soil. And these are installed, when you combine them with subsurface drainage, they are installed perpendicular to the subsurface drainage pipes at a 3 to 6 feet spacing. And as I mentioned in the previous slide, mold channels create cracks in the soil that helps water movement downwards, and that's good, that's helpful. But the conditions are that you need a heavy clay soil. For more information, I invite you to read the extension bulletin about mold drains on the Michigan's drainage website. If you have an existing drainage system, the first one I talked about was mold drain. The second one is that you can actually add surface drainage to the system. And surface drainage is a cheaper option than tile subsurface drainage system. Well, we've got to make sure we prevent surface water ponding without causing erosion. Excess water in the system flows over the naturally or artificially sloping ground toward the shallow ditches or grassed waterways. You can see these two diagrams. The one on the left, we got a slope in two different directions. It's like a crown. And then the one on the right, the field slopes in one direction, but these shallow ditches or grass waterways intersect surface runoff. So that's helpful. That's going to take care of some of that extreme heavy rainfall that's going to come down, where the soil may not be able to handle it in terms of the infiltration and means runoff. But this will help improve the drainage system. In North Carolina, I know we visited Muhammad's site. They have these surface drainage systems in some places. So we talked about the existing drainage system. Let's see what if there's a new drainage system. We would want to use shallow drains. Another option is the choice of pipe material. These two. Let's take a look at these two. So shallow drains that are installed at a narrower drain spacing are going to lower water table more quickly. And that's going to be helpful because it's going to reduce the risk of crop damage from waterlogging conditions. It's going to help lower the water table and get into the field for field operation. And that also helps retain more moisture in the root zone, reduces crop drought stress in dry conditions. Compared to a drip drain, that soil profile is going to be drier because the water table is going to be deeper. And this increases crop yield under certain conditions. This is based on our research with DrainMon. Another interesting thing is that with shallow drains, you're going to reduce the year-to-year crop variability. For example, year 1 and year 2 and year 3, you're going to have about the same yield. But if you have a deep drainage system, your yearly annual yield is going to have greater variation. So it reduces yield variability. This is something new that we found. Another thing is that shallow drains reduces the total water drain. That's important. It reduces the total water drain over the year. And over that year, you're going to have fewer days of flow with the shallow drains. So what does that mean? That means it's good for reducing nitrate loss. It's good for water quality. Another thing is that this shallow drains is not limited to just, for example, relatively sloped fields like controlled drainage. It's going to work on sloping land, rolling land, without the need of any kind of management. So that is comparison with controlled drainage. So for the new drainage system, I explained the first one, which was shallow drains that are going to lower the water table more quickly. Another one is choosing the right pipe to remove water more quickly. So let's take a look at that. So if you want to install the new drainage system, I talked about the first method of going with shallow drains. The second one is the choice of pipe. So if you are in a condition where drain sedimentation is an issue, you basically have three options. You can go with a photo sandslot pipe, 8-row sand slot pipe, and you can go with a saw crab pipe. So the research showed that the saw crab pipe removes water much more quickly than the 4-row sand slot pipe. If you ask how much, well, let's say you got a 30 feet spacing and 2.5 feet drain depth, the one with the sock is going to remove water. It's going to have a higher drain inflow by 29% compared to the 4-row sand slot pipe, and that's huge. That translates into several hours. It could be up to 5 or 6 hours if you want to lower the water table from the surface to 30 centimeters or 1 foot. So that's big. That's important. The choice of pipe matters, and I've drawn it in the same order from 4-row, and then the second fastest 8-row, and then the fastest is the saw pipe. So let's take a look at the reason. What is happening with the sock? So the saw grab pipe functions as a completely open conduit without walls. Just assume you got an opening conduit that doesn't have walls. It's just like mold drains. So that would mean that the snitted sock pipe is going to maximize water entry into the pipe. So this is the fastest it can go because it's functioning as a complete open conduit. So the take-home messages for the choice of pipe: the most important property of the pipe is the number of rows of perforation. 8-row is much better than 4-row, and 8-row is going to remove water more quickly than a 4-row for the same pipe material. Imagine that. You're paying the same, but you're going to get better performance. The second most important property of the pipe is the slot length. Longer, narrower slots are going to be better than shorter, wider slots. And slot width has minimal effect on the water inflow. So, we don't have to, when we look for pipes, I heard from a person that a good pipe for them is that the one that they hold up and it has wide slots so they can see sun go through the openings, the perforations, but that's not true. You could have the longer, narrower ones is going to be better than the shorter, wider ones. And shorter, wider ones are actually, you'll be able to get a lot of sun go through them because it's bigger. But the slot width has a minimal effect. So overall, go with an 8-row than a 4-row. It's going to get you faster drainage. So I talked about the drainage system. I talked about an existing drainage system where you can add mold drains if the conditions are right, or surface drainage. That's one way to deal with the heavy rainfall. Another scenario was a new drainage system where you could pick a right choice of pipe, the 8-row, or in the drain sedimentation issue, if you could go with the saw crab pipe. And that would help. And also shallow drains that can remove water more quickly than deeper drains. But that's on the drainage system, that's on the field. What can you do downstream of the drainage system at the edge of the field? And this is the photo of a flooding. That's going to be a big damage. Actually, from all the natural disasters, flooding is one of the most devastating, economically damaging one. It's really devastating. So let's see the flooding. So what can we do to reduce the damage from floods? The key is to store water on the landscape to dampen the peak, reduce the peak, and take the energy and reduce the energy of the water a little bit. We could do there are several methods: groundwater recharge. Wetlands can store water on the landscape. Detention ponds, retention ponds, these are for storing water for urban stormwater runoff. There's 2-stage ditches. I'll explain that a little bit more. Drainage water recycling, of course, that has a storage or a pond on the farm that can store water. That's a key method there. Controlled drainage can dampen the peak That's another one. Saturated buffers and wood chip bioreactors are also, because they have a controlled structure, that can be implemented with controlled drainage in the first chamber. So that's another one that can dampen the peak, slow down water. So let's look at the two-stage ditch. So let's look at the two-stage ditch. This has potential to reduce flood peak. The reason is that look at the figure A, that's a conventional channel, but look at the second one, figure C, with a two-stage ditch. When the flooding comes, water has a lot of energy. So the energy of the water moves and dissipates because it's moving into the flood plain. So that water has less erosive power. That's the damage from the flooding. There's the need for research in this to quantify how much flood can it reduce.
All right. I think that was the end of Ehsan's presentation there, and he gave kind of some very practical, like even on the technical aspects of the collecting from the tile that you choose. I was a little interested in hearing some more about some of the practices that he described there toward the end, and controlled drainage was one of those. And I believe Charlie Schaefer is still on the call, and maybe Charlie, if you'd want to jump on here, and if you can share your, or not share your screen, but at least turn your video on and maybe give us the quick rundown of automated drainage water management and the potential that we see with that practice that's out there.
Oh, thanks, Keegan. Yeah, this is Charlie Schaefer with AgriDrain Corp. Both speakers bring a lot of interesting comments to this webinar, and it's exciting to think about improving soil health and aggregate stability and infiltration rates, and also intensifying our subsurface drainage systems through design and also product utilization of some of these different pipes that Ehsan's discussed. And to think about Eric's charts there that show these large scale rainfall events, and 3 times more likely for the 2-inch in Iowa and twice as much in Illinois. I wonder if, as we think about this and ways we can manage these water levels and flow rates in subsurface and surface water applications, we spend a lot of time trying to do that and trying to engineer the system so we can take advantage of storing some of this balance and not letting this water go, and maintain the nutrients. So we focus both on the agronomic aspect and the environmental aspect. But as you look at some of these charts and look at these rainfall events, have we got pretty good science on what to expect? I don't know if Eric's still on with us, to what to expect in terms of some of these large scale rainfall events and the flashiness of the system, and how we may be able to utilize automation to offset the unintended consequences.
And I'm not sure if Eric's still on there or not, or maybe I had to step away real quick there, Charlie. But yeah, that's exactly, that's why I asked the question about, the summer dry periods. We're hearing all this data about the increased wetness in the rain, and then going into these long summer dry periods, so we need to figure a way to, hold that water back and be able to deal with that unexpected. Oh, great.
Sorry
yeah,
about that. My family was just getting ready to leave, and I went in the other room, but I'm back here. Can you repeat the end of that? Because I caught the beginning, but not the very last second.
Well, to think about how intensive we're making these drainage systems, and the way the rain is coming to us now in larger events and greater variability. As you project out, and I'm sure you do, you look into the future, and we think about automation and ways to more aggressively and actively manage these subsurface and surface water, these drainage systems with automation. Have you looked at some of the potential benefits and some of the potential downside, the risk if we don't do it?
I mean, the downside risk is always, I think, easier for me to see and think about. And what I mean here is that we have such a long history of understanding what not staying ahead of your soil erosion issues looks like, right? Go back to the Dust Bowl, to even what we saw in the 80s, and then of course lately. And so it's easy to focus on that, and that mainly revolves around the inefficient use of nutrients, the loss of your topsoil, And then the fact that a lot of what does drain will eventually end up in a big, huge waterway that has downstream issues. So what I think about here when we look at the projections, because I have no reason to not think that the trends we've been seeing don't continue. There's just no evidence to say that it's going to reverse and go back and change, which means basically greater variability in precipitation across the board, and then increase rainfall rates east to decrease west. So when I kind of stitch all that together in my head and say, if we have better ways of storing water locally, I mean, I talked to that farmer in the video I showed you of the saturated buffer. We had one of the wettest springs on record on his field in April, May, and June. It did not rain on his field in July. There's no rain. That guy, because he had the water stored in that buffer, reversed it and put it right back in his tile from the buffer. You know, what a great way to store everything right there on site. So I think about all of these local management practices, how they might stitch together with, you know, what Levi, Mark, others were talking about with the big drainage projects that are happening, like the one around Fargo with just redirecting the water. I think it's going to be a multi-systems, multi-scale approach to handling it. And I honestly don't know who the top minds are in the field thinking about it right now. And maybe some of them are on this call.
I think most of those people are on this call right now, so we'll put that plug in right now. But no, and actually, speaking of the top minds here, I sent Chris Hay a message to talk about one of those other practices that Ehsan listed there with with the drainage water recycling, and that's the very thing, you know, storing that water on the landscape and getting it back to the field when it's needed. So Chris, I'm not sure if you can jump in right now and maybe turn your video on if possible, but at least kind of give some thoughts on what you're seeing with drainage water recycling.
Sure. And yeah, it gets back into the meat of this discussion that, we're looking at these same trends of increasing rainfall in bigger events, but then longer periods without rainfall in between those. And so looking at ways to try and increase resiliency of these systems. And so, one of the things we've been looking at is this idea of actually recycling drainage water. So can we capture that water when we get it in those big events in the spring and store it on site to actually be able to reuse that as supplemental irrigation in the summer. And so, if you get in there in July and those key crop development periods of, tasseling and pollination, that when you really need that water, but if you don't have it, that's a way to have that water to be able to use it as irrigation to supplement that. And so, the nice thing about it is it really sets us up for a win-win that, the farmer gets that benefit of that supplemental irrigation and that reducing the yield variability, increasing yields overall, but then we also get a water quality benefit from that those same nutrients that are in the water that would leave in the spring, if we can hold those and recycle those back in the field, we also get that downstream water quality benefit.
Yeah, great. Thanks, Chris. I think we're getting close to closing out, but once again, open up to anybody that has any further discussion points if they want to jump in here and maybe turn on their video and join the chat or just enter into the chat. I think now is the time to do that.
If I could toss out one more thing just to think about, and I'm curious if anybody in the group was a part of these discussions, but one of the things that I find most, the word's not alarming, but most, it rents a lot of space in my brain. Let's just leave it at that. Was back in 2007, we had the signing and the ratification of the Great Lakes Compact. Have you all heard about this? This is basically where the states that surround the Great Lakes plus the 2 Canadian provinces put into law a set of rules and regulations that the biggest of which, for what I'm concerned about, stated that under no circumstance can water be trucked out of the Great Lakes or piped out of the Great Lakes. So when you think about these water issues, I think it's just critical to keep a national and international perspective on water issues, because today we didn't talk about South America, right? That's out of our purview. We didn't talk about what's going on across Europe. You want to talk about water regulations, get into the 28 nation states that share rivers in Europe, and then you've got yourself a whole other mess. You think about what's going on across the waterways in Africa, and then of course throughout Australia. And all of a sudden these discussions become so much more of a water scarcity issue. It's who has the water and who doesn't, who owns the water rights. So that's just something to keep in the back of all of our minds as we think about some of these bigger picture issues.
Alex Eccles did correct you and said they did make an exception to export water in the beer cans coming out of the Great Lakes states. So always on top of it. No, this has been great, Eric, and we thank you for your time, and I hope we can have some future discussions. You know, we do a lot of work. You asked who the kind of experts in the room in this space are, and this conservation drainage network that I mentioned a few times, and I can send you some of the information. Is really what this conservation drainage network is aimed to do. I see Sean has his hand raised. I'll let Sean jump in here and provide some comment. You might be muted still, Sean, if you're talking already. Oh, okay, I'll find your phone number here. 1 second. Maybe. There. Can you unmute yourself now? All right, now try it, Sean.
Okay, can you hear me?
Yep, there we go.
All right, you can hear me now, fantastic. Yeah, so building on Chris's comments, I had a question for perhaps Chris Hay, perhaps Alec Eccles. I was wondering what, if any, changes need to be made to the Farm Bill to enable cost share payments for some of these innovations. I know in Mississippi, they've been doing pipes and pads and tailwater recovery for over a decade, basically capturing runoff, albeit not subsurface ag drainage, and then piping it back into ponds and using that later. Typically after a very wet spring, they can get 55 inches followed by a dry summer. So there's precedent for NRCS to pay for this type of practice, but are there statutory changes that need to be made, or administratively, are there new practice standards that need to be established to pay landowners and farmers for those types of innovations Chris Hay was just talking about?
Well, I guess I can start that. Actually, I worked with a group of folks, including Ruth Book, who's a retired engineer within RCS, but we actually took that conservation practice standard that was developed with the Mid-South in mind, where they're doing the tailwater recycling, and now have changed that to where it's irrigation and drainage tailwater recovery. And so that has been approved at the national level. So that opens up the possibility of being able to fund that practice through EQIP. Now the states need to adopt that national standard, and I'm not sure where individual states are in that process.
Just to elaborate a little bit, I think the authority's there, and Chris has hit the nail on the head. What we don't have is the will, and we need to have state cons, state engineers, folks in the top leadership at NRCS say, if we're going to deal with this great big elephant in the room, we really have to step up our conservation drainage activities. It's actually declined since the Obama administration. And, it's less now than it was in the Obama administration. And it's because we don't have somebody in headquarters pushing it like we did back then.
Okay, well, thanks very much for that call out, Alec. I'm sure there's a lot of people on this call who could help with that.
Well, in fact, we're looking at the annual April meeting on conservation drainage, perhaps being in the East Coast, so that either on the way to it or on the way from it next April, Everybody can swing through Washington and meet with their elected officials and say, you know, we don't care if you're for or against dealing with whether it's climate change, but we're seeing weather variability and we can solve that. And we can help keep farms profitable. We can help keep agriculture feeding the world, and we can improve environmental quality. And I think that's a critical missing point that we have not sufficiently driven home to have the political leadership.
Great point, Alec. And, you know, it plays into not only food security, but energy independence and national security too. Yeah, I think a fly-in is a great idea.
All right. I think we're up against our time limit here. And Tom, if you're still out there, I'm wondering if you couldn't wrap us up here. I'm happy that you let us commandeer one of your growth committee meetings for this discussion, but I think this was great, and hopefully we can keep some momentum moving forward.
Yeah, thank you, Keegan. What a great presentation by Eric, and tremendous information and really helpful to this greater conservation cause. So I really do appreciate that. And I think there's a lot of great ideas, and kind of as Alec mentioned, we now need to try to bring those to fruition as a collective group. There's great opportunity for improvement of agricultural water management. It's one of the key ingredients moving forward. And I think there's a tremendous amount of interest in this group, and hopefully we can foster and continue to move that forward. So thank you very much, Eric, especially for your efforts, Keegan, for you coming up with the idea, and appreciate everybody's participation. Thank you.
All right, well, thanks everybody. With that, I'll stop the meeting. We will make a recording available later if people want to go back and catch up on what we discussed today. But thanks everyone, and we'll see people later.